Hi students, today I am going to explain what is operator in physical chemistry. So what is an operator? It is a rule that transforms a given function into another function. So it is a mathematical function which is help to give another function. So operator is a symbol for a rule for given mathematical function into another function. So and it does not have any physical meaning if it is written alone. I will explain it with one example. For example, square root. It is an operator. So when we don't write any number, just if we write square root, is there any meaning? So it itself don't have any meaning. But if we write number, so root of 4, then we will get one number. So it will give another function. So an operator is a symbol for a rule of given mathematical function into another function. It transforms into the number of its square root into another number. Yes, no? So root of 4 is 2. So 4 is one function, 2 is also one function, and it is a rule. Like this we can tell. So there are examples of operators I gave. So differential operator, if I tell differential operator d by dx, then it is a function of first derivative x. Then d by dx sin x is equal to cos x, or d by dx it is the first differential derivative with respect to x. If I tell d by dx into x square, then the answer is 2x. Then d by dx x cube is equal to 3x square. Like this we can write. Then what is there in the operator? Let's see. So operator a cap, we can mention it as a cap. Operator a cap is fx of operator of function fx is equal to, it will give another function gx. So operator of fx is equal to gx. It is the general formula of the operator. Then we'll see algebra of operations. Let's see addition and subtraction of operators. A cap plus b cap f. So it is the addition. Then it is equal to a cap f plus b cap f. When we see subtraction of operators, a cap minus b cap f is equal to a cap f minus b cap f. So this is the operator, and so it is a function and it is another function. So when we take one example, 9 plus 5 plus 3 is equal to 9 plus 5 plus 3. So it will give same. So from this we can tell that multiplication and addition, these are commutating. So what do you mean by commutating? What is the rule of commutating? Let's see. First let's see what is multiplication, how to do. So a cap into b cap fx is equal to a cap, when we take it in the bracket, b cap fx, that is equal to a cap gx is equal to hx. So a cap b cap f, when we are multiplying a cap with b cap f, then it is equal to fn. So and we have to take the multiplication of two or more operators. We should follow the from left to right, we have to do the multiplication process. So what is commutating? If a cap and b cap are the two functions, then a cap into b cap is minus b cap into a cap is equal to 0. Means if these two are same, then it is commutating. When they are not equal to 0, then it is non-commutating. So different types of operators now I am explaining. So first one is linear operator. So an operator a cap is said to be a linear operator if its application on the sum of two functions f and g gives the same result as the sum of its individual operators. If the sum of the two functions will give the same result as when they are added individually, then it is called a linear operator. For example, a to the function f plus g is equal to a f plus ag, and that is equal to a cf, that is equal to caf, where c is the constant and f and g are the functions. So let's see it. For example, d by dx, this is the d by dx, it is an operator and the functions are f and g. So d by dx f plus g is equal to df by dx plus dg by dx. So summing up separately, so it both should give the same value. So for example, 3f plus g is equal to 3f plus 3z. So these are the examples of linear operators. We'll say non-linear operators how it will be. For example, root f plus g. So when it is in the square root, then it is not equal to square root of f plus g, square root g, or 1 by f plus g, and it is also not equal to 1 by f plus 1 by g. We know that in the fractions LCM we should take, and it is not same. So these, when the sum of both operators is not equal to sum of separate operators, then it is called non-linear operators. When the sum of the two functions is same as the individual operators function, then it is linear operator. That's all. Next is Laplacian operator, or it is also called space operator, and it is represented by delta square. So delta square is equal to psi square by psi x square plus psi square by psi y square plus psi square by psi z square in the 3 axis 3x y z. So this is Laplacian operator or space operator. And the next I am going to tell is Hamiltonian operator. Hamiltonian operator means the operator which is corresponding to the total energy of the system. It will be the sum of the kinetic energy and potential energy, and it is denoted by H cap. So total energy of the particles with respect to mass and velocity under potential V is equal to, so sum of kinetic energy and potential energy. So H is equal to P square x by 2m plus V xyz in the 3 axis xyz. So when we take 1 by 2m as common, so P square x plus in the 3 axis we are writing P square y plus P square z plus V. So when we take H cap, so this operator when we apply, so 1 by 2m is equal to, here also we will get all the caps, that's all. So P cap x square plus P cap y square, P cap square y plus P cap square z plus V cap. So we know that P cap square x is equal to H by 2 pi I psi by psi x. Because it is 2 are there, so we are multiplying 2 because it is a square. So that is equal to minus H square by 4 pi square psi square by psi x square. Like this we can do for y and x, z axis also. So at the final we will get H cap is equal to H square by 8m pi square. We took it as common, leaving only the psi square psi x square plus psi square by psi y square plus psi square by psi z square plus V cap, like that only. Then, so we know that psi square by psi x square plus psi square by psi y square plus psi square by psi z square is Laplacian operator or space operators, that is denoted by delta square. So here we can represent like this. So H cap is equal to minus H square by 8m pi into delta square plus V. So for m particles we can write H cap is equal to minus H square by 8 pi square psi 1 by mi delta square plus V cap. That's all. Next is, what is Hermitian operator? If these two are the two functions belonging to class Q function and alpha is an operator for that, then psi and one more, then the alpha is said to be the Hermitian operator. That's all. And we gave the equation, so psi star into alpha psi dt is equal to, just it is reversing, so that is equal turnover rule. So this is the Hermitian operator. And the next is momentum operator. The kinetic, potential and total energy are derived from the coordinates of momentum and position. So in this momentum operator we tell whatever is the energy, kinetic energy, potential energy, total energy. So these are derived from the coordinates of the momentum and also the position. So let's see that. So the momentum operator can be derived by using a fundamental property of electron wave itself. So psi is equal to e to the power of minus plus or minus 2 pi I x by lambda, where if we differentiate it, d psi by dx is equal to plus or minus 2 pi I lambda into a to the power of e plus 2 pi I x lambda. So this is all equal to psi again. So we wrote like this. but we know that lambda is equal to, according to de Broglie's law, h by px. So d psi by dx is equal to plus or minus 2 pi I h px psi. So px psi is equal to, so we took it that side, so plus or minus h by 2 pi I into d psi by dx, that is equal to px is equal to plus or minus h by 2 pi I d by dx. So like this we can write the momentum. V is nothing but momentum here. Then angular momentum L, it is given by vector product of position and linear momentum P. Howda? Yes. Then if we take I, J, K are the unit factors along x, y, z coordinates, then R is equal to position R is equal to Ix plus Jy plus Kz. So and the linear momentum is equal to P Ipx plus Jpy plus Kbz. We just added P here. And linear momentum is equal to, it is the product of position and linear momentum. Yes, no, R into linear momentum. So we multiplied these two, and here we took I as common. So I is equal to Ypz minus Z pi V plus J into Zpx minus Xpz plus K into X pi V minus Ypx. That is equal to linear momentum is equal to I Lx plus J Ly plus K Lz. Like this we can derive. Thank you.